Well, we actually started working for a company called Acorn, who had the contract to design the BBC Micro, which was a home computer to teach kids in the early 80s how to program. And that was a very successful project, and we were then looking around to develop its successor.
So show me some of your original chips that you first designed 25 years ago.
There were 4 chips in the original design, each one about the size of a £2 coin, and they went together to form a desktop computer which was then sold to the public.
So as you said, they're about the size of a £2 coin, and it's a series of squares within squares within squares. As far as I'm concerned, there's sort of a dark brown outer layer followed by a green layer, by a gold layer. I mean, I'm doing a rather pants job at describing it, but what are they?
Well, the microprocessor is kind of the heart of it. It's like an engine in the car. It's things that actually makes it drive and does all the hard work. And then you build around it all of the bits and pieces that turns that engine into a car or a motorbike or a bus.
Where are we today then? How do your chips today compare to these 4 chips?
Well, if you took those 4 chips and made them on a modern technology, they'd actually shrink down and you'd fit 35,000 of the new ones in the space of one of the original chips, which means you can take all of the things that it takes to build that desktop computer and shrink it down into something that's a cubic millimetre, which is actually small enough that you have it on your palm of your hand, you can hardly see it. And when you've got a computer of that kind of power in a cubic millimetre, you can start to put it into just about anything.
What do you think was so successful about your chips?
Well, I guess we had 2 things going for us. One was the original design was all based on being really small, simple, which meant it was low cost, it was low power. And as the world transitioned from desktop computers into mobile devices and ultimately smartphones, having that really efficient small core has proved to be technically what's driven our success. But at the same time, it's about the business. We decided we couldn't do the whole thing. We couldn't design all of the chips to do all of the products that we thought we should have. And so we came up with a business model whereby we just licensed our designs to people who wanted to make chips. And then each company we sold that design to actually finished it off with their own bits and pieces. So some people turned it into mobile phone chips, other people turned it into anti-lock brakes in cars, and it all had our technology in it, but we ended up getting designed into just about all of the electronics on the planet. Now, the downside is we only get paid a small royalty. Every time somebody sells one of our chips, we get paid a few pennies in royalty.
Given that you only charge a few pence per microchip, that must mean you're selling a lot of microchips.
Last year, there was over 12 billion chips shipped. Over the total lifetime of ARM, that's something like 75 billion chips have gone out. And yeah, it's in everything. All of the stuff that you don't necessarily think about having being a computer that actually has buttons and switches and a display on it, that's probably got ARM technology in it.
You're just going to take over the world?
Slowly and politely. But what's funny for me, of course, is I've been with ARM for 25 years and it tends to blur. I can remember the first 2 or 3 years and I can remember the last 2 or 3 years, but the 20 in the middle, we've been running so hard and the world keeps changing. And I guess what makes ARM really fun is next year is going to be very different and the year after that will be very different again. And it's that constant change that's actually what makes it really exciting.
Too much champagne. I was going to say the blurring of all things in between. What do you think the future is of all these chips?
Well, I think it goes in 2 ways. Obviously, the technology gets faster and faster, more complex, and your smartphone does more and more, and it starts to understand what you are, who you are, what you want to do, all of the kind of predictive technologies that start to anticipate what your needs are. But at the other end of the spectrum, we're working with a small local company here that's doing transistors printed on plastic. So it's like cling film. They're not very fast, they're not very advanced. It's like the technology was for making these chips 25 years ago. But once you put it on cling film, you can start thinking about wrapping it around 3-dimensional objects. You can start putting computing into all manner of devices that you haven't got there today.
Wow, I'm just imagining wrapping myself in cling film and being like a Christmas tree.
Well, smart clothing is one of those things. There's the things you do with building sensors in, so it knows what your heart rate is, it can measure your respiration. So yeah, there's lots of exciting things you can do.